Alright guys, welcome to your 18th physics lesson, and in this lesson, well, before I go on with this lesson, I probably want to mention this. My guess is that you watched the last video and you remember me talking about force pairs, and you now understand the concept behind a force pair, how you can have an object and it can have two forces of equal magnitude but opposite direction, thus causing zero acceleration. Pretty much the object doesn't move at all. So that kind of makes sense to you. But then you thought of whenever I said this. You know how I said that Newton says that if you are standing on Earth, that gravity is pulling down on you with the equal force that the Earth is pushing up on you. And you said, okay, I'm not moving, must be force pair. Gravity, of course, I understand that force, I know what that is. But how in the world can the Earth be pushing up on me? That doesn't make sense. Well, it doesn't make sense to a lot of people, so what I'm going to do is I'm going to try to explain this without the use of a watermelon tree. So, the first thing I want to do before I draw my little diagram is, let me just go ahead and write this equation. Force equals mass times acceleration. Now I want to write that just because I'm going to refer to it a couple times, but imagine this. Say you were sitting in science class and the teacher brought out two rolly chairs, and these rolly chairs obviously look a lot like boots. Now, of course, the rolly chairs are the ones that you probably have at your computer desk with 3 or 4 wheels on the bottom. Now, these weren't ordinary rolly chairs. These rolly chairs were facing back to back, and they're connected by a spring. Now, you were sitting in one chair. Here's your little arm and your head like that. Let me draw your head a little bit bigger. You guys are smarter than that. And in the other chair, your teacher picked the fattest guy he could possibly think of in the class. So here's him, and here's his arm. He's probably eating like a cheeseburger or something already. And let me draw his eyes. Ah, get in my mouth. So it's you right here, skinny mini, and over here, huge, humongo, fat guy. So again, everything else is the same except obviously the weight, aka, well, let's just say the mass, even though mass is related to weight, as you already know. So now you're just sitting in these chairs and your feet are off the ground, both of yours, and some dude walks in the middle, we'll just say this is your teacher, and he pushes both of these chairs away from him. He pushes both chairs in the opposite direction. So like this, he pushes you to the left and Fatso to the right. And I know it sounds mean, but guys, I'm just trying to teach physics here. So what would happen in this case? Well, obviously, what would happen is you would go flying, and this guy right here, he would move, but he would really only move a little bit. So why would he only move a little bit and you would move a lot? Well, that is because the force is the same, but the mass is not the same. You are so much more less massive than this guy over here that you have greater acceleration with the same force. So why am I talking about fat guys and you sitting in chairs? Well, this is exactly what happens with you and the Earth. Even though you guys have the same force, aka he has the same strength in each arm to push you guys away, this occurs on Earth not with a fat guy, but with Earth. So just imagine that Earth is a really fat friend. Fatter than this guy could ever be if he ate all the cheeseburgers in the world. Basically, what happens is, like I said, Earth is a really fat friend. And since this fat friend is so massive, any changes in its acceleration is so small that it's almost unmeasurable. But that doesn't mean that it doesn't exist. The force is still there, even though when it pushes you, it's very easy and apparent to see. But whenever you have a force like you jumping on the Earth, you move it, and you indeed move it, but it's so small that no instrument that man can ever make will probably ever be, accurate enough to measure it. So, like I said, Earth is just a really fat friend. So, hopefully you understand now, and if you don't get all upset, because the truth is, physicists don't really understand totally how gravity works yet. And if you're saying, oh yeah, they do. They know how to calculate it. They even know that more massive things can cause more gravity, such as Earth can cause more gravity than the moon. Well, yeah, they know that stuff. They know how to figure out equations, and they know it has to do with mass. But physicists still don't know why gravity works. Kind of weird to say, but it's still one of the big mysteries. They think it has something to do with something called gravitons, or excuse me, gravitons, which is supposed to be the subatomic particle that we can't even see. But anyways, I'm getting way off topic here. I didn't even mean to talk about that. But if you guys don't understand still, then that's probably because no one does. Gravity is one of the biggest mysteries.